Okay, so if you've ever wondered what was inside a Makita Torch, well, you're about to find out. So I'll tell you what we'll do. I've actually lost my Makita battery, I don't know where it's gone. And that's the negative. And then this one's the positive, I think. So I'll just hook this up to a car battery. There it is. This is actually an 18 volt. The car battery is only 12 volts, but it's just a torch. So, oh yeah, look at that. It goes on and then comes off again for a brief blip. Right, so we better work out what's going on with that. Right, so the screws are out. I'm not sure how you get this off. There's a spare bulb in there. You can take the cap off, that just screws off. So I have to say that seems to be remarkably loose. I don't think that's the source of the problem, but it's probably not helping. So I've actually got it off with a bit of levering. So I'm sorry I couldn't show that because it was actually pretty difficult to do. So still can't get that apart. So there's the reason why. There's another screw just there. Oh, there's actually a circuit board inside this. I can't believe that. Really? Oh, they've actually got a circuit board in there. In a torch? Well, that's a weird one. So this lifts off and there's a spring, you don't want to lose that. And then I would guess that probably lifts off. No, that's not lifting off, right? Oh yeah, it does lift off, yeah, so that lifts off, orange wire downwards. The switch just comes away, so we can test that. Then we've got PCB, and the rest just lifts out. That's just a contact plate. And there isn't actually much on the circuit. It's pretty simple by the looks of it. Okay, so I've got 18 volts attached there. So the circuit isn't doing much. So there's no dip out on it, so it doesn't look like it's shorting or anything like that. So we've got two contacts here. I'm not seeing any real problem there. However, yeah, I'm not getting anything there. So let's just check. There's obviously no voltage there because I think that bulb's okay. Okay, so I don't see any dry joints, but one observation is to make there is this: the two contacts that feed the bulb with the voltage, they don't come from the switch. They come from this PCB. The switch goes onto the PCB, and there's obviously like a power transistor switching current through or something. Not really sure why they've done it that way, but maybe it's so they could use a low voltage bulb or something, I don't know. But that means that it's possibly not the switch. So we'll test the switch next. So there's my switch rigged up to the bleeping effect on the meter. Continuity they call it, I think. That's looking like a few ohms, which I would say is actually too high, but it might be the way I've got it connected. That's me just holding the multimeter directly onto the switch, and that's still like 3 ohms and falling. There must be some capacitance in there of some kind. Well, there is a little bit, I suppose. But that seems like a good strong. It doesn't seem to me like that's a faulty switch, so there's no need to take that apart or anything. If we check this, we'll check the little capacitor in there. Well, fingers and thumbs here. You look at that. It's coming up at megohms. So very. It's trying to get it on there when it is. So that's kind of what you should see, really. You don't really want it to be a low. Yeah. So when you first put the probes on it, it might seem a little low at first because it will be charging up fast, kind of thing. So I've got a diode test because there's a couple of diodes in here. And we'll just check these diodes. .66, that's good. So we'll swap the probes around. And then test that one is... Ooh, that might be blown, maybe. That was .54. Okay, so it appears that if you kind of draw out the circuit, they've got a resistor right across the input. I don't know what the heck that's for, so I was just going to measure what that was. So I had a look at the bulb, and the bulb is definitely 18 volt rated, so that's like a 100k resistor across the input there. So I don't really know why they've done that. That's peculiar. So the capacitor isn't shorting. The diodes actually do look okay. I might do a quick test on these transistors, but I don't understand what the purpose of this is for, because there's only an on and an off switch. So maybe we could just bypass it, probably, and get the thing working again. Okay, so the only thing I can think of is that with these Li-ion batteries, you don't want to discharge them to the point at which the charger can't pick them up again, because it's like a safety feature. If the voltage drops below a certain level, then you will get very, very high charging currents. And so for safety, if your voltage drops below a certain level and you've discharged the battery too far, the charger will actually say, nope, you're not having it. So I think maybe that there is created in such a way that when you get below or just above the safety cutout on the battery charger, it will essentially stop the torch from working. I think that's probably what it is. However, it doesn't work on 18 volts. I've just tried it on the power supply earlier on, as you saw. If you look at the output of the torch, we have a bulb, which is driven by a PNP transistor. So we've got basically what looks like a reference circuit here, and then this TL431, which is kind of what I thought it was. It's an over and under voltage detector, and also a reference source like a Zener diode. So what I'm thinking is, when we turn the torch on, we get a blip, a flash, and it goes off again. So that suggests to me that that's working, and that's probably working. And this is like a reference circuit of some kind, because it goes into the reference of the TL431. And we have basically a CO15, I think. Quick look. A C9015, which is like a small signal transistor here. And when you turn this on, this is the only capacitor in the circuit which is going to charge up, cause a current to go through this, which will cause that reference to work briefly. But then when it charges up, there's no current, so the reference won't work. This is probably supposed to supply that current, but it isn't doing it. So I'm going to suggest that the the C9015 is actually a faulty part and needs replacing. I don't know why Makita have put a 100k resistor right across the two lines. I mean, that's a bit of a strange one. It's not going to take much current, that at 18 volts, but that's a strange thing to do. I don't really know what they did that for. But anyway, so I'm going to go and try and replace that transistor, the C9015. I do have some C9014s, but they're not quite the same. But I might just try them in there quickly and just see if they work. Okay, so according to my little diagram here, the base is on the right hand side. When you turn it over, it's going to be on the left hand side. So if we put the probe onto the base and then onto the collector 0.634, sorry, the other one, the emitter, 6.34, so that gives me confidence that that's probably just okay. According to my little diagram just there, the CO9015, the base is in the middle, and it's also a PNP, so it should work the same way. No, that's actually okay, that. Well, that's interesting. So we've checked the capacitor and that transistor looks just fine, and then the big transistor looks just fine. So it could be, what could it be? It could be the reference, which we can check with the voltage, putting the voltage on, or it could be one of those little diodes that's just there. So it's probably that transistor or that. I think it's probably that one. So this is the TL431, which is it behaves like a Zener diode. It's like an IC shunt regulator. So it's a regulator effectively. So I've found one here off another board, and I'm going to try it. I don't know if it'll work or not, but we can order these quite easily. They're not hard to find. So, well, folks, so we have been through, as you can see, 3 different components, and let me just show you a quick demo. Just because I feel like victorious right now. There you go. Let's put that right in the shot. There you go, we fixed it. So, the problem. The problem was this, the power transistor. And do you know, it tested, the junctions tested fine, and I just couldn't understand it because it just appeared to be okay, which was a really strange one. Who knew that a power transistor could fail in a torch? I mean, that is astonishing, but I guess they can. This is not a static sensitive part, it's a PNP transistor. So I did change this, and no avail. Obviously nothing wrong with the old one. And I did change that, no avail, nothing wrong with the old one. Just in case some of you are trying to fix one of these torches out there, if you measure this circuit and you're getting at 2.5 just here, that's the bottom diode and resistor off the negative line, then I believe that's correct, and you should be getting something like about 1.8 at the collector. Yeah, I think that's right, 1.8, and where the base meets this divider of resistors here, you should be getting 0.7-ish. So the problem is, when I was putting the voltage probe onto the base here, I was getting 17 volts. So I kind of eventually thought, well, we'll better change that transistor. I was going to buy one on eBay, but I actually took one off an old board, and it's actually an equivalent, which is a DA82 instead of a B772. So we can now clean up the torch and put it back together. I think that's correct. And then the switch, probably the black red one goes underneath, and the switch one goes on the top. No, that black one goes underneath, and the switch goes over that, and then there's a little rubber grommet in there. Must come out the back. That's it. There you go. So this piece here goes into your top there, and I think it should come out the other side. Yeah, that's right. Well, perhaps I've got the wrong. Oh yeah, I've got the wrong spring in there. Oh, where that one came from. Yeah, that's correct. Yeah, that's not going to short, so that'll be fine. Right, I may have to look over the videos earlier on and just see if that one came from anywhere. I don't quite understand that. Ah, yeah, of course, yeah. Right, so we've got these. Yeah, that's right. We've got these little pieces here, which are the torch's sort of ratchet, and they go in the top like so. It goes on like that. So sorry, I don't have any fancy screwdrivers with motorised screwdrivers or anything like that, so you have to put up with me doing this. Right, so I guess you don't want to be trapping your screws like that. That's not a good idea. Wires, don't trap the wires. Trapping wires is not good. Right, that won't go together because I think there's something trapped inside, so I'll have to get off again, which is a bit annoying. Whoa. That's interesting, because if you look at the kinch on that wire there, it looks like it has been trapped before. Tell you what I'm going to do. I'm going to put a bit of electrical tape on it. Do they need to flex? No, they don't actually. No, they don't need to flex at all. I'll just put a bit of electrical tape on it. That should hold it down. I'll put the top on. There you go, perfect, look at that. Okay, so there we are, and right, so these little things here, which are sprung, so that goes in the middle, obviously makes contact with this piece, which we'll deal with in a second. And then if you carefully look, you see these little lines here. These are like the ratchet, where you can turn the torch at different angles. and that's what those are for, those little plastic bullets. Right, so the bulb holder was a little bit loose, I thought, so I'm just going to tighten that up a little bit. So I'm just going to use some very fine pliers and just bend it just a tiny wee bit, not a lot. Right, I'll just check that the bulb can actually go in. Yeah, it can. It's still really loose. So this part of the unit, it goes in the opposite side to the one that's already in there. And then we've got just a single screw which holds it on. So if you just look down there, you can kind of see where the contacts are coming up, and then the bulb goes in, and I'm hoping that when that gets pushed with something, well, it holds the bulb in better, but I don't know, you know, it's not really doing a great job. Right, so we should be ready to reinsert this. There's two long springs, pieces of spring steel with chrome. They go down the side of this, and they come out here. You can just see one of them there where my finger is, just there, sorry. And when this presses against it, it presses quite hard, and it should push that in. So we'll soon find out. So we've now got to get this on, and it is quite hard to get this off again, so I hope it works. Yeah, that's the ratchet that I was talking about. Could maybe do with a little bit of grease on it, but it's okay, I think. So hopefully now the bulb will go in. Nope, it's still loose. Right, I'm going to have to solve that somehow. Okay, so I made a small modification. As you can see there, just put a little screw in there. So that seems good. Doesn't seem like it's going to fall out or anything. So I don't know. Well, it's certainly working now. So, there we go, one Makita Torch. Top job, sorted out. So if anyone wants a circuit diagram, you can just pause this video short if you want. These are the pinouts. This is the 772, this is the 9015, and this is the other one, the T431A. All very common parts. I mean, I scrounged them off an old power supply, so they're very common. And it turned out to be this one that was faulty. I did change this, and this is the one that fixed it. Interesting enough. Some issues with the bulb. Okay, so that ends this video on the Makita Torch. So the next up for the videos is this, found this LX saw, and the Makita Torch was an LX too, as it happens. And I was just going to quickly plug it in and try it, but I cannot move that switch, and I cannot move that switch either. That one won't move, and that one won't move. that probably doesn't move because that doesn't move, but I don't know why that doesn't move, so that's going to be the next video, folks. Thanks so much for watching. Bye.